If you're wondering why I chose this picture, it's because old code tends to blow in your face like that, or maybe because you secretly feel like doing this to your code, whichever you prefer. So about myself, as she said, project rescue expert, legacy fixer, developer, conference speaker, trainer, and quick plug, I also co-organize a conference called confu.ca. So I've been helping with the selection of the speakers, so it's almost ready. Should be out, the schedule should be out sometime this week. So just go there and see some Ruby talks. All right, let's say you inherited 10-year-old code base. Maybe it was a 15-year-old code base, or maybe even 17. Here's the thing about code. It doesn't age like wine. It ages a bit more like cheese, so it tends to smell a bit. So what was the web like back when that code was written 17 years ago? Well, it was 600 pixels wide. So this is a screenshot of Yahoo back in the day. What happened also in 2000? We had obviously the Y2K bug. We also had Internet Explorer 5, which was pretty cool. So if you don't like IE6, then imagine what life was like with Internet Explorer 5. ICQ was only starting to be cool. And rounded corners. If you could do that, you were the cool kid on the block. So your code was written around this time. So it makes sense that when it was written, the web was pretty young. People didn't carry over all of the knowledge from the other programming types. So they didn't quite follow all those clean code standards that we have been promoting for the last 10 years or so. So I used to be a consultant for a very long time. I got a new legacy project every few weeks. And what I want to do is share some of the stories of the things I've discovered and advice on how to deal with all that code. So let's talk about code smells. And the thing is, you might find some of those in the code base that maybe have just been written. Because when we say legacy, there's also a term, legacy by design. And when it's legacy by design, it means that a project could have been shipped maybe a month ago, and it already has those code smells that you would normally associate with really old code bases. Because as it was written, some ideas about what the product should be like changed, and so people changed a lot of the code. There's dead code, there's other things. And here's an example of a code smell. Mixed concerns. So in the same file, let's say you have access to the database, then you have some business logic, right? And then you also have some HTML output. So, and maybe even if you really like that, you do a connection.exec directly, not even going through active records, like if you feel really adventurous. And it happens. Some people write code like that. Then you can have poorly named variables like A, B, C, Z, Z25 because you run out of letters. Or you can have array, or you can have item 1, item 2, item 3 in a bunch of loops. You have no idea what's happening in there. Those are code smells. Other things, a whole bunch of includes everywhere instead of having some sort of autoloader properly configured. Then you can have abuse of static methods. Now, static method calls in themselves are not a bad thing. Sometimes they make sense. But there are people who use them so often that they forget to actually even instantiate objects. And if you're not instantiating objects, you're not doing OP. You're basically just namespacing your functions. And when also I say about a bunch of includes, that's like an include file with a whole bunch of functions which exist globally, and you can call them from everywhere. Like, raise your hand if you've already done that before. Just include a functions file. No? Okay, I'm surprised. Maybe you're a bit shy, you don't want to share that. It's okay. Or sometimes you have a call to a method, but then you have a dev mode. And here's an interesting thing about dev mode. When you have those global constants, you can get yourself really in trouble, especially if you're not configuring your environments correctly. I had a code base where somebody created that dev mode constant, But depending on which files they included, it could have been a different value. So between two requests, you could go from dev mode to something else, to like production mode, without even knowing, because you're including a different file that has a different value for it. And the other thing is what the developer did. He also created another constant called payment gateway test mode. So you could assume that you are in the dev mode, but you also have to make sure that the credit card flag is set to dev mode, because if it's not, then you could be testing a batch operation and run a whole bunch of credit card charges to your clients, your actual clients. So yeah, beware of those global constants. You can also have inexplicable conditions. So if the order ID is greater than 20,117, use this SQL. If not, use something else. What happens on order 20,117? I don't know. Maybe the way the data is now stored in the same tables has changed, but the person, instead of migrating the data to the new version, the new definition of the data, they decided to just change how the code works. But the problem is then, unless you stumble upon this and you're writing some new feature, you would not know that historic data is going to not be displayed correctly. So whenever you find something like this, I call it a weakness, and it's time to refactor. But if you do not have time to refactor right away, what I recommend you do is just bookmark that line. Just put a comment there, fix me something. And when everything goes to hell, you will probably find the answer in that block of code. So at least you'll have a memo. Long methods, very long methods. It doesn't matter what it does, it's a long method. It can go for pages and pages. Like, I've seen methods that are hundreds of lines of code, and people find it okay for some reason. Or maybe you have a method that accepts 20 arguments. That's also another problem. It's just really unwieldy. So when I deal with legacy codes, this is from some of the projects I worked on average between 3,000 and 6,000 lines of code in a single file. Half of it is commented out, just in case we need it later, because source control is too mainstream. So then they have a single method that can be 800 lines long with a whole bunch of ifs, and it becomes really complicated. I personally, if you ask me, I try to keep mine now as much as possible under 10 lines of code, if at all possible. I used to have a higher threshold, but recently I've been practicing and reducing that as much as possible. So at most I'll have maybe 1 or 2 ifs in there, which means that it's very easy to test. And you can just look at them and know whether they work most of the time. The other thing, and I mentioned that earlier, a lot of helper classes. So there's no mixed concerns. Sometimes no classes at all. Does this ring a bell? Have you seen projects like that? Yeah, you did. Who are the veterans here?
We're too embarrassed to speak up.
I'm sorry?
We are too embarrassed to speak up.
Yeah, it's not pleasant to work with those kinds of projects. The code base was, so this is a project I worked on about a year and a half ago. 5,000 classes, 20,000 methods, 1.5 million lines of application code. So it does not include the framework, it's just the application itself. And it's not just one project. It's a lot of projects are similar to this. And when you stumble upon them, it might seem impossible to refactor them because there's so much code. But the thing is, with good methodology and enough practice, you can tackle them. And after a while, you'll be like me, where I look at those code smells and some really, really bad code. I'm like, mildly impressed. Where other people would just run for their lives. So before you code, you have to make a strategy. You cannot just go headfirst into the project and start changing things. The strategy is, well, the strategy will be based on some constraints. What are those constraints? Think about it as a house. You want to change the rooms, you want to refactor your house, basically. There are certain walls that cannot be moved because otherwise the roof collapses. So those are, in your project, those are the constraints, certain things that cannot be moved. So once you identify those constraints, you can start stripping things around them. You can do either a full rewrite or a progressive rewrite. And I would strongly advise you against a full rewrite, and there are many reasons for that. When you do a full rewrite, what happens is it takes a long time. You can just run out of steam. And even if you don't run out of steam, let's say it takes you a year to fully rewrite the project. During that year, you are not working on new features for the product that you have. You are rewriting something. But then also in that year, not only are you not bringing any value to the existing product, you are, what happens is that when you do need to make some changes in the old code, now you have to replicate those changes in both code bases. So you kind of still have to maintain the other one for bugs. You cannot just let it rot for a year and come back to it, because then the business will die. So a full rewrite is almost always a failure, either on the technical side or on the business side. I would say more than 90% of the time it is a total fail. So you can do a progressive rewrite, and there are many strategies for this. You can rewrite a single class. You can refactor it, move things around, or just rewrite from scratch and make it clean. You can rewrite an entire feature, like a module, for example, something that kind of makes sense to rewrite all at once, that doesn't have too many dependencies. Or if you're writing for the web, you can rewrite by HTTP call. So every page is a single HTTP call, and you can change that, by request, basically. But then you wonder when you do this progressive rewrite, how do you make code run side by side? Because you have this shiny new code, maybe it's like a completely isolated feature, or an HTTP call. How do you make it run side by side? The only big things that you have to consider are really just database or any external services you're using, and session sharing. And if your session is stored in a database, then you're pretty much covered. So the code itself is not a problem. And then when you create separate HTTP requests, you just need to do a mod rewrite, and I will show you a more complete example of how you can just say, this page pointed to a completely different application, and it's going to handle it in a novel way, but will still connect to the old database. So from the user's perspective, nothing changes. Their session is maintained throughout the pages, and they have no clue that a completely different application is now serving this particular request. But before you start, make sure to take some precautions, because you can lose data, you can break things. First, do a backup. And when you back up the database and the code, try to restore it to see whether it still runs when you restore it. So that if you lose everything, you will not come to your backups and realize that maybe they're not there, or maybe they're corrupt, or maybe they're incomplete. Because I've seen that happen many times. Even I once did a dump of the database, but it didn't suck in the views and other things and the stored procedures by default. And so there was a database without those things. Luckily, I had a different backup, but this backup was no good. It couldn't run because code was accessing those views. When you back up data, or when you even put it onto your machine, make sure to nullify any sensitive data. When I say nullify, you can use different terms, like where I work, we call it anonymize. So this is something that I've always did when I hired also outside consultants who are subcontracted. I would not give them a database. Like some clients I had contained credit cards in plain text in their database. And it was like the top priority to refactor, but it was there. So in order to test things, I had to send the database over to someone or even keep it on my computer. I am not comfortable keeping on my computer so many credit cards in plain text. So what I do is I can identify all of the sensitive data and replace it with something different. For example, for the credit cards, you can replace them with test numbers. For every Visa, MasterCard, they all have like those test numbers. I think it's what MasterCard is 4111111. If you have emails, you can like just create bogus emails, like put a hash in front and then add some example domain. This way, if you have any operations that send emails, even if you take care, sometimes the dev mode is not on by accident, so you're not spamming existing clients from the database. Things like that, just identify all the data, strip it out, make it still somehow usable, sort of valid, but nothing that can affect the outside world. Have staging, where you will simulate all of your deployments, upgrades, any batch processes you want to run, anything that communicates, with the outside world. You probably want to run it on a server that is as closely, or if not an exact replica of the production environment. So you have to analyze the production environment carefully and you have to replicate it so that you will never deploy something to production that has not already been tested under the exact same circumstances. I would highly recommend to automate tests before you code any changes, and I will cover some of the tests that you can write. And then you have to make a risk assessment also, because you might think that something is a big deal, but maybe for your employer or your customer, maybe it's not such a big deal. For example, if I say, well, what happens if I just once accidentally double charge when I do my test? Just one, The client says, well, it's not a big deal because we just cancel the charge, send an email apologizing, and it takes like 20 seconds. I'm like, oh, okay, so I'm not gonna write like a whole big wrapper around it if I just need to test something once and if it's easily reversible. So you might have to discuss those risks frankly and see what's the real status of it. So don't be too optimistic, also because certain things can have nasty side effects. For example, let's say you creates an incorrect amount on the invoice and then it charges people, but then not only do they have to figure out how much was overcharged, they have to revert just that portion, but then they have also to update a bunch of stuff in the database because there are other things that have been updated based on that amount, and reverting this may be very difficult. So certain mistakes are more costly because they have side effects. So you have to look at that, but at the same time, not too paranoid because certain things are really not a big deal, even though you might think so. Ask before. Some clients can stomach more risk. When you want to test your application in development mode, make sure that you test with real legacy data. Don't try to reconstruct it from your understanding. Like if somebody says, oh yeah, it's supposed to be like this or like that. Oh yeah, sure, let me write some fixtures here for the database. It's going to contain that. And okay, it works with those fixtures, great. But then you come to the real database in production and everything explodes because there are so many things you haven't accounted for. And just one developer somewhere across the ocean maybe has this knowledge locked in his head that was never documented. And he says, oh, right, yeah, I forgot to tell you this thing could happen. Oh, but now we have to change a lot. So,
Order 20,117.
Yeah, something like that. Exactly. I mean, you could not know. I had a case recently where users were associated to, multiple users could be associated to multiple accounts through an intermediate table. So I assumed, of course, that, that's how it works. So to check for permissions, I just need to do an inner join and everything's going to be fine. No. There was this exception where, because of some legacy, some historic reasons, they used to have the account associated to only, the user only associated to one account through a foreign key. And only later did they do the many-to-many relationship. So some of their data would not contain, some of their user accounts would not contain a link to the account, or the users will not contain a link to the account. You just have to go through the foreign key. But if it has more than one account associated, then there will be entries in that table. And you could not have known that. Yes?
Is that the case where you have this if below 20,000?
No, unfortunately that's the different. No, I have so many examples. And this one I just remembered. It wasn't even part of the presentation. But it was fun. But actually it's the one that made me write these tweets. When I saw that, I'm like, of course, like never again will I trust a developer telling me, yeah, sure, this is all the information you need. No, there's probably more, especially when dealing with an application that's been running in production for a while. So here's an interesting example of a rewrite that failed catastrophically. It was a project where a consultant decided to move from PHP 3 to PHP 5.6. And so in the original code base, of course, PHP 3 did not have object-oriented programming, and so forget MVC or anything like that. So everything was in one file. And you would just call that file, and it will process and render. So the HTML, the PHP, and SQL was all in the same file, includes all over the place, ifs that concatenate SQL, or choose that, or yeah, it's just really complicated. And you can have another if in the included file that concatenates to a variable that's available in the scope of that of the original file. Anyway, really complicated. So he tried to do a rewrite attempt. He failed, made things worse, because not only in the past there was just one legacy code base. Now we have two. Like at least when you deal with legacy, if it's just say one developer or just a couple of developers who implemented it, there's a certain philosophy, and once you get into the head of the person who was there before you, you sort of start to get it, and you know where to look, right? You get those patterns. But now there are two patterns for bad code. And you don't immediately know which one it is. Well, you can do git blame, but you know, not all code is in Git, unfortunately. Because you know, people just comment out lines and stuff like that, or do rename the file to .bak, you know, backup. So, or underscore old, or even maybe a timestamp. So there were folders of dead code because the person didn't even clean up the things that he rewrote, and you know, static functions everywhere, no instances. So why would you move from a procedural language basically to object-oriented and not use object-oriented programming? I don't know. Oh, and about object-oriented programming. Back in the day, I was working at a gaming company, and we often received things from outside companies, like little games to incorporate into the bigger platform, like mini games. And so this company sends a project, and we open it, and we gave them the instructions. You know, it has to be OP, all the bells and whistles. Comes back, one class, everything's inside of it. They never instantiated. I mean, they instantiated the class once and just like basically have a main in there. So my colleague said, well, of course, we do have an object. Now we just need to orient it. So I find it really funny. It still sticks. Like, I don't know, 12, 13 years later, it's still in my head. So the solution for that specific project is that it was a progressive rewrite. Like even to this day, not all parts of this project have been rewritten. We rewrote some of the more complex, like multi-step forms to an MVC framework, and with mod rewrite just pointed to the correct URLs. And rewrote one of the biggest features, which was the billing module, to OP, because the stuff they were doing with SQL queries would no longer cut it with the new requirements for some of the things they need to calculate. It just wouldn't work with. We reached the limit of what SQL could do. So we had to rewrite it properly with OP. And we did design extraction, which I'll cover in a minute. We ended up with a more flexible architecture, automated tests, and the benefits were visible immediately. Not just that we reduced the technical debt, but by eliminating so many bugs at once, we were able to charge, I think, like 10% more. So basically sales increased 10%. I mean, people still owe that money. We just didn't know it because the calculations were wrong. So it's an easy way to gather the money. And it took me only 40 hours to implement that. Basically, I was going to a conference in South Africa, so on the plane there and on the plane back, I had time to finish it. Because it's like 30 or, I don't know, 20-something hours in each direction, because crazy. It's really, really far. So yeah, we had this great rewrites, and I said, well, here's how much it costs you to do the rewrites, and here is, from the first week, how much more money you're getting from the system. It already paid for the time that I worked on it, and more. So sometimes the effects are really instant. I would recommend that when you write any new feature, it should not take longer than a sprint. I mean, it sounds obvious to those who do agile, but if, say, you consider 2 weeks a sprint, if it takes you more than 2 weeks to rewrite, then don't. It has to be complete within the 2 weeks, like ready to go to production. Now let's talk about design extraction that I mentioned earlier. It's a known process, actually. Although back in the day I did not know that it was a known process. I thought I invented it, but then I read about it somewhere else. I'm like, oh no. So what happens with legacy is that the client or whoever wrote it initially, or actually let's talk about a client. The client knows how things are supposed to work, but not how they are implemented, right? And the developer who worked on that is long gone. So you have this code that nobody knows how it works, and things do not work as the person wants them to work, but sometimes also the client does not realize that certain things are broken because they never see the code. So they don't know that there are bugs in there, like in the calculation. Like, how would the person know that the calculations are off unless they do them for every single case manually, which they can't because there are so many permutations. And the thing about this code is if you try to rewrite it one for one, let's say you look at a line of code, you cannot just rewrite it better, or even a method, you cannot just rewrite it better. That's not how you rewrite an application. You have to change the design. You have to come up with something much better, especially if it was written 15, 17, 20 years ago. So if you try to rewrite one for one, you will almost, even if you just look at the code, you will be biased by how it works right now instead of how it's supposed to work. So you will see something, you're like, oh, right, and then it will just unconsciously make you re-implement the same bug. So what you don't want is to reintroduce the same bugs and flaws, and so the process is you take the old code and you create design documents from it. So you look at some complex process, and it's funny because actually I did it just today. I looked at some code. I had no idea how it was working. I looked at it. I saw some flaws. I extracted the design. Basically, I created a flowchart to describe how it works. For another client, I did just like a decision tree because that's what they were concerned with. So I created created design docs from the code. And then I validated that design with the client. So in case of that billing module, I validated with the person. We clarified the rules, changed some of the things because I'm like, well, here's how it works. Why is it billing like this? No, it's supposed to be like this. Oh, okay, so we just found a bug. Let's change it. So we change that and we come up with an entirely new design. So let's say it's a flowchart, we come up with a new flowchart that is simplified, maybe splitting objects a bit, limiting the concern of each object. You come up with a new design. So now what you have in hand is a new design, a design for something that you are going to implement. You can throw away the other one completely. That's how you do proper rewrites of an application. You throw away the old code, let's say an entire module, you don't care about it, because what you are faced with now is specs, technical specs for something new that you want to write. So just go ahead and follow the specs, ignore the rest. You have everything you need in order to write the new code. And that is the best way to have, to reduce technical debt, to create the most flexible design as you can come up with. And if you're ever wondering whether non-technical people can understand, design documents, some design documents, like even flowcharts, are something that people can read. Like any person can read a flowchart. Almost any person can read an ERD. You just have to explain what the concept of the entity, and before long they're going to grab the pen and they're going to scribble other things. They're going to say, oh no, but we also need this entity. And it happened to me many times. So enough with the whole design extraction. Now let's talk about fixing the specific bugs. I usually say if you touch legacy, you have to improve it. You have to leave it better than when you got into it. Of course, if there's anything wrong with it. If it's the most beautiful piece of code that you've ever seen, just leave it and follow the example. But if there is obvious technical debt, improve it, and that way you will remove the debt. Not just that, but you're still probably going to need to scribble some notes or maybe do a little diagram to just understand how it works. So might as well put it to some good use. So if you touch legacy, improve it. So when you start fixing bugs, what happens often is you find code duplication. And in one project that I had to, where I had to fix bugs, pretty easy bugs actually. The hard part was that the same bug was duplicated 80 times because person just copy-pasted everything. And they had basically 80 views of similar objects, but instead of doing something that is generic and then changing just what needs to be changed, no, they copied everything and just replaced the values. So when you find something like that, remove them as soon as possible. So refactor it basically to have like a centralized, for that case I created a centralized view and I used variables for all the things that were different and just fix the bug then once and it was no longer a problem. Because these code duplications get bite you really hard, you can fix it in 20 places but you forget the 21st and then it's going to happen to someone and you're like, didn't I fix that bug like a month ago? Oh no, yeah, I found another version of that code that's lying somewhere. Hopefully you can regex match and find something similar, but you're not always thinking that way. So yeah, once you start fixing bugs, you want those bugs gone for good. So make sure that this code does not appear in other places. Now, one of the hardest thing I find to change is those really long methods, like 800 lines of code. I was working on a calculator for flight pricing. So you know how flights are really complicated to price? Like their logic is really complex. But for one company, it was like everything in one method, like 800 lines. So what I did is that I wrote unit tests. And sometimes you might not be able to test all the scenarios for that big method because there's just too much complexity in there. You might not know everything it does. But you can also write unit tests for just the part that you need. You write the unit test for basically the bug that you're trying to fix specifically, and then you change as little code as you can. Let me start over. You have a big method, you grab the part where the bug is, and you move it to a completely separate method. Okay, so you just wrap that logic. Now that method, you then unit test it. So because it has an input, it has an output, you can just test it without bootstrapping the whole thing. Test it very simply. The first test is obviously going to fail because the bug is present. Then you fix it, and then you run it again, and then the test is green. And then from that big method, you call that smaller method. So now you have a fixed bug, and you have a test to prove that you fixed the bug. And the thing is, you can do this, iteratively. You find another bug, you move that into its own method, or you can spend some time and move every code block into its own method. So how do you decide where to split? Let's say we have this method, and we want to rewrite all of it. We want to refactor the entire method. Usually, code inside those methods is written in blocks, and those blocks are generally preceded by a comment stating what this block does. Oh, here we're doing this, and here we're doing this, and this block of code is responsible for that. This is a good place to split, because they're like logical blocks. They do just one thing. And let's say we're doing like a script that parses a CSV of user groups, or conferences, and it gets their location, their coordinates on the map based on the address. And from there, it saves it to a database, and now you can display them on a map and see, oh, here are all the conferences around you. So these are the comments that are written on top of these blocks. So what you do is you grab, as I said, you grab that part, and you put it into the sole method, and you call that method. And then just repeat it as many times as needed until all of your large method is basically gone. All the code is somewhere else in much smaller units. And how do you call them? It's actually pretty easy. Usually following the pattern of the comments. I mean, not automatically, but if the comment says extract stuff from a CSV, okay, well, let's call it conferences from CSV. We are getting the location coordinates, call it location coordinates. We're saving the conference to the database now, call it save conference. So you will pass a conference object to it, and it's going to save it to the database. Really simple. Maybe we'll construct, add some things with some logic, change some properties, and save it. And that's a very simple approach to refactoring. Let's talk about another example of a rewrite, one of the bigger rewrites that I had to do for clients. I was hired once to help a client moving an ASP Classic application. So for those of you who don't know, there's ASP.NET, and what used to be called ASP is now called ASP Classic, just to avoid confusion. Because some people say, I work with ASP, but they probably mean ASP.NET, because ASP Classic no longer has support for over 10 years. I mean, it's dead. So if you have still code running on ASP Classic, it's pretty bad. So they wanted to move to, they didn't even want to do ASP.NET because it's already too different, might as well do it with PHP, they said. It was like back then it was 15-year-old code, now it's probably more like 20. That was a while ago. So yeah, the language no longer supported. It was this huge ERP with so much code, it was like a beast. It was really scary. So the solution was to rewrite page by page, once again, with mode rewrite for the concerned pages. So how does that really work, the rewriting of page by page? So let's say you have the regular application, and then you're going to tell your web server, for this particular URL, instead of pointing to a project folder here, point to a different project folder. Like, start a different application, and that application will have its internal routing system for those paths. Okay, so for example, in their case, it was like something/something/something, which refer to actual folders on their file system, and then .asp, that URL says, it's still going to be the same URL, but instead of going to the ASP application, it now would go to a completely different PHP application, which used the proper framework, MVC framework, and it was really clean. And then they would do that for every page. As soon as they rewrite a new page, they're basically rewriting it from scratch in a framework, and they point that new URL there. So they just collect a whole bunch of mod rewrites. It can be a lot, but in the end, when all of them, I never saw the whole process through because that was like a multi-year effort. But eventually the idea was that once you have all of those URLs, all of those pages migrated, you can just pull the plug on the other, remove the mode rewrite, point everything straight to the new application, and it's all done. So that was the strategy implemented. The problem with ASP Classic was that the location for storing sessions was some obscure container within ISP. Okay? Sorry, ISP. IIS. Thank you. ASP, yes, within IIS. It was like this container, and the PHP application had no access to it. It was not available. So what they did is, their developer, who was very good at ASP Classic, wrote a little adapter to, instead of putting the sessions in there, to store them in a database. And then on the PHP side, we just had to access the same database. So when you come to a page, you just read the cookie, find that session, and you're authenticated on that, you're authorized on that page. So they can go like from a page that's served by ASP to a page that's served by PHP, and then to another page that's served by ASP completely seamlessly to the user. Their session is maintained throughout the whole process. And that's the beauty of HTTP, because an HTTP request is stateless. I mean, nothing really happens. Besides the session, there's nothing happening. There's no magic, really. It's just inputs. The input is what? URL, headers, you know, the body, and that's it. And whatever you have in the database, in the cookies, cookies are headers. So what is more to that than, you know, just replicating the same input or responding to the same input and providing the same output? So when you think